Hey guys, I'm Code Crazy Logic, and today we have an AMC 10b problem. And it states, in square ABCD, points P and Q lie on AD and AB respectively. Segments BP and CQ intersect at right angles at R, with BR equaling 6 and PR equaling 7. What is the area of the square? And they actually give you a diagram on the actual test, which is shown right here. But without further delay, let's go ahead and get right into the video. Okay, but before we get into the problem, we need to cover a theorem explaining how to do the problem. So in this theorem, we have a triangle ABC, and altitude CD is drawn. And using that, we can make these conclusions. So let me elaborate on what I just said. So CD is an altitude to this triangle, right? So what an altitude is a line drawn from one of the points to its opposite side. And when that line is drawn, a 90-degree angle is formed, aka a right angle. Now let's look at the conclusions we can make. So the first one is saying CD squared is equal to AD times DB. And CD is basically the altitude, as I mentioned before. We multiply it by itself, so it's squared, is equal to AD, which is part of the opposite side, times DB, another part of the opposite side. So basically, it's the altitude times one part times the other part. So let me write that out. Okay, so now that we have that, let's go on to the second conclusion we can make. And that is AC squared, which is one of the sides, is equal to AD, which is part of the base, the part of the base that's like opposite to that, I guess, times AB, which is the whole base itself. So this is saying that side squared is equal to part of the base times the whole base. Or as I like to say, it's short times long, as that helps me remember it. Okay, let me write that out. Okay, let's look at the final one we have here. So this one is saying BC squared, which is one of the sides again, is equal to BD, part of the base, that's opposite to it, times AB, the whole base, like I said before. So this one works the same way, it's just the other side. So it's basically the side squared is equal to part times whole, or short times long. Okay, so I would recommend you memorize these because these are really important in geometry problems. And if you can't remember like the exact triangle and the exact words, what I recommend you memorize is these words right here, as it's a simpler explanation as to what is really going on here. Okay, without further ado, let's go back into the problem. Okay, I'll give you a quick sec to reread the problem again. Pause the video if you want more time to figure out the solution for yourself. Okay, welcome back. Let's get into the solution on how to solve this problem. So the first thing you want to notice is that triangle APB is congruent to triangle BQC. And I'll explain why in a bit, but let's write that out real quickly. Okay, let's prove that. So the first thing I noticed when I solved this problem was that AB is equal to BC as it's a square. So let's write that out. And we also have that angle A is equal to angle B due to both of them being right angles because it's also a square. And finally, we have that angle PBA is equal to QCB. And that is because if we let C equal A, we have this part as 90 degrees. And we have this as 90 minus A. So also B is equal to 90 degrees. So we have 90 minus A plus something is equal to 90. And if we simplify this, we get that A is equal to question mark, which means that A is here. So we have that PBA is equal to QCB, and let me write that out really quickly. And now, because we have two angles in one side, we can call this an angle side angle congruence. So therefore, the sides, the triangles, are equal. And this part isn't super duper important to this problem, so that's why I kind of rushed that. Okay, now that we have that piece of information, let's put values for QR and RC. So because these triangles are congruent, we have that PB is equal to QC. And PB is actually equal to 13, so QC therefore should equal 13. So we don't know the values of like RC and QR. So what we can do is make RC equal to X and QR equal to 13 minus X. And if you add them, they still equal 13. Okay, what we want to do is look for a triangle with an altitude, since we have our formulas that we discussed before. And a perfect triangle for this is actually BQC. So let me draw that out really quickly. Okay, now we have this triangle right here. So if you remember what formulas we covered at the beginning of the video, you would remember that altitude squared is equal to part of the base times the other part of the base. So using that, we can do 6 squared is equal to 13x. So using that, we can do 6 is equal to 13 minus x times x. So let me write that out. And now we just have to solve this quadratic equation really quickly. I'll speed this up because it's just factoring. Okay, so now we have x minus 9 times x minus 4 is equal to 0. So we get the values x is equal to 9 or x is equal to 4. Let me rearrange them so it's in numerical order. And actually I flopped these. Let me rewrite them so it's actually this but turned around. And just looking at the diagram, you would think that x is greater than 13 minus x. So we would want to have 9 and 13 minus 9, 4 as the values here. Since usually the diagrams that the AMC gives you are really close to scale, so we shall use these values for now. So let's plug these values back into here. And what we can notice is that we can find the side length of the square if we just do the Pythagorean theorem from RC and RB. Since it's a right triangle and we have 9 and 6 as those values. So let's do that. So 9 squared plus 6 squared is equal to BC squared. So BC is equal to the square root of 9 squared plus 6 squared, which is equal to 81, the square root of 81 plus 36, which is equal to the square root of 117. So now that we have what BC is equal to, we just have to square BC and we get the whole area of the square. Because all sides of the square are equal, so we just need to do one of the sides times itself and we get the answer. So we just need BC squared, and that's equal to 117. And that's the area of the square. So the correct answer is D, 117.
And coming back to the values x equals 4 and 13 minus x equals 9, if you use those values, this wouldn't actually work out, since 4 squared plus 6 squared equals 52, and that does not equal any of the answer choices.
And actually a quicker way that I just missed was you could just do BC squared and we know that's the area of the whole square. So we could have just solved it from here and gotten the answer much faster. Okay, so anyways, we solved the problem. We finished number 15 of the AMC 10B, which is one of the later problems, so I would say it's one of the more difficult problems. So I'd like to thank you for watching this video. Leave a like down below and subscribe if you learned something new from this problem. And I'll see you in the next video. But until then, stay crazy.